Welcome student to Praveen Patil College of Diploma, Engineering and Technology behind the East. Subject Applied Mathematics. Myself Mrs. Smita Shekhar Kamble. Today's lecture is obviously depend on chapter number 9 for mechanical engineering student only, that is probability distribution. Last lectures we discussed about the normal distribution. Now we have to take the further example based on that. The mean score of 1000 students in an examination is 36 and standard deviation is 16. If the score of the student is normally distributed, how many students are accepted to score more than 60 marks? Mean is given, that is mu is 36. Sigma, that is standard deviation, is 16. Number of students 1000. We know that z score is given by x minus mu upon sigma. X is equal to 60. Z is equal to 60 minus 36 upon 16. 24 upon 16. 3 upon 2, 1.5 is the z score. Px greater than 60, Pz greater than 1.5. P x greater than 60, P 0 less than Z less than infinity, minus P 0 less than Z less than 1.5. Graphically, Z is equal to 0 to give the symmetricity, and we have the point 1.5 to the right hand side of the graph. We have the negative infinity and x quantity is greater than 0. So that's why we have to take here the 0 less than z less than positive infinity minus p 0 less than z less than 1.5. 0 less than z less than infinity is 0.5 and 0 less than z less than 1.5 0.4332. Subtracting 0.0668. Probability of one student to score more than 60, 0.0668. The number of students accepted to score more than 60 marks out of 1000 students, 0.0668 into 1066.8, that is 67 approximately. When x is normally distributed with mean 12, standard deviation is 4, find Px greater than equal to 20, second P0 less than x less than 20, Px less than equal to 20. Mean mu is equal to 12, standard deviation sigma is equal to 4. Now z score is x minus mu upon sigma. First example, x greater than 20. So x 20 we have to consult, z score is equal to 20 minus 12 upon 4 is 2. So we have highlight the z is equal to 2. X is equal to 0, z is equal to x minus mu upon sigma, x is 0, mu is 12, upon sigma is 4, minus 3 is there. So negative lies in this quadrant. When x is equal to 12, means what? 12 minus 12 upon 4, 0 upon anything is 0. X greater than equal to 20, Pz greater than equal to 2. So obviously greater than equal to 2 means we have to subtract P0 less than equal to Z less than equal to infinity minus P0 less than equal to Z less than equal to 2. This portion we have to cover. 0.5 minus 0.4772, 0.0228. It is the Z score and this probability we have to define. P 0 less than x less than 12, P minus 3 is there, less than Z less than 0. We have to take the reverse way, 0 less than Z less than 3. So at exactly 0.4987. Third one, P x greater than equal to 20, P Z less than equal to 20, that is 2 we have to consult, with P minus infinity less than Z less than 0 plus P 0 less than Z less than 2. We have minus infinity less than Z less than 0, 0.5 it is fixed, but addition is there, 0.4772, 0.9772 is the final answer. We have to highlight this way, 0 less than x less than 12 this portion and Px greater than equal to 20 this portion we have to cover. In an aptitude test administered to to 900 students, the score obtained by the student are distributed normally with mean 50 and standard deviation 20. Find the number of students whose score is between 30 and 70. Mean, obviously mu 50, standard deviation 20, number of students 900. First, we have to highlight the z score here, x minus mu upon sigma. First question is given, find the number of students whose score is between 30 and 70. So between portion is there. So first we have to find x is equal to 30 and x equal to 70. Separate z score there. So z is equal to 30 minus 50 upon 20 is equal to minus 1. And x is equal to 70. Z is equal to 70 minus 50 upon 20 is equal to 1. We highlight here it is exactly minus 1 and 1. So that's why minus 1 lies in this quadrant and 1 lies in this quadrant. So we have p 30 less than x less than 70, p minus 1 less than z less than 1. We have to distribute minus 1 to 1 in both the two parts, that is p minus 1 less than z less than 0 plus p 0 less than z less than 1. P 0 less than z less than 1, P 0 less than z less than 1, because the minus probability is not included in a z score form. 2p 0 less than z less than 1, 2 into 0 less than z less than 1, how much is given? 0.3413. That's why 2 into 0.3413 is equal to 0.6826 is there. So therefore, find the number of students whose score is between 30 and 70. It is obviously we have to define 0.6826. Probability of the student score is between 30 and 70, 0.6826. Now we have to find the number of students whose score is between 30 and 70 out of 900 students is given. So obviously we have to multiply by 900, 0.6826 is there. So multiplication 614.34, it is approximately 614 we have to consult. In a sample of 1000 cases, the mean of certain test is 14 and standard deviation is 2.5, assuming the distribution is to be normal. How many students score between 12 and 15? And how many students score above 18? We have frequency 0 to 0.8, 0.2881. Frequency 0 to 0.4, 0.1554. Frequency 0 to 1.6, 0.4452. X bar is 14, sigma 2.5, n is equal to 1000. First, z is equal to x minus x bar upon sigma. 12 minus 14 upon 2.5 is minus 0.8. Z score x minus x bar upon sigma. 15 minus 14 upon 2.5 is 0.4. So now we have to solve the score. We have to establish the number of z score we have to find. So we have to go to establishment of the 12 and 14. We have to consult. So first 12 to 15 we have to consult this way, and we got the 0.44435 is the probability. That's why number of student n into p is 1000 into 0.4435, 443.5, that is 444. Z is x minus x bar upon sigma 18 minus 14 upon 2.5 is equal to 1.6. P above 18 is a greater than 1.6, 0.5, a 1.6, 0.5 minus 0.4452, 0.0548. Therefore, number of students n into p 1000 into 0.0548. So 54.8 we have to consult that is approximately 55. If the 10% of component as manufacturing the company are defective, if 12 components selected at random, find the probability that at least 2 will be defective. This example totally depend on which probability distribution? Yes, it is exactly the binomial distribution. P is equal to 10%, 10 upon 100, 0.1. N is equal to 12. Q is equal to 1 minus P, 0.9. PR is equal to NCR, P raised to R, Q raised to N minus R. At least 2, 1 minus P of 0 plus P of 1, 1 minus 12c 0, 0.1 raised to 0, 0.9 raised to 12 minus 0 plus 12c1, 0.1 raised to 1, 0.9, 12 minus 1. Simplify using the scientific calculator of 82fx we include the 0.3409 is the final answer we have to consult. Weight of the 4,000 students are found to be normally distributed with the mean 50 kg and standard deviation 5 kgs are there. Find the number of students with weights less than 45 kg, between 45 and 60 kg given for a standard normal variate z area under the curve between z is equal to 0 and z equal to 1 is 0.3413 and that between z is equal to 0 and z is equal to 2 is 0.4772. In this way, x bar is equal to 50, sigma is equal to 5, n is equal to 4000. So now already we have given the hint 0 and 1 is given that 0.3413 and z is equal to 0, z equal to 2, 0.477. It is a hint to evaluate the answer in this form. Let us find the z score for x is equal to 45. Z is equal to x minus x bar upon sigma. 45 minus 50. 50 is the what is given? Mean. Upon 5. Sometimes they given the word is average there, that is suitable for these examples. So 45 minus 50 upon 5 is equal to minus 1. P in bracket less than 45 we have to kg in we have to find. A less than minus 1 is there. 0.5 is the actual value we have to evaluate for the 0 to 1 basis. So obviously 0.5 minus A in bracket 1. A in bracket 1 0.3413 is given 0.5 minus 0.3413 0.1587. The number of student n into P 4000 is equal to 0.1587 is 634.8, that is 635 is there. Now second question is given between 45 and 60 kg we have to find. So for x is equal to 45, z is equal to x minus x bar upon sigma, 45 minus 50 upon 5 minus 1 is there. And for x is equal to 60, z is equal to x minus x bar upon sigma, 60 minus 50 upon 5 is equal to 2. We have to find the probability between 45 and 60, a in bracket minus 1 plus a in bracket 2. 0.3413 plus 0.4772, 0.8185 is the final frequency between the 45 and 60, that is the probability we have to consult. Therefore, number of student n is into P 4000 into 0.8158274 is the final answer between the 45 and 60 kg and less than 45 kg is 635 out of 4000 student. In a sample of 1000 cases, the mean certain test 49 standard deviation is 2.5, assuming the distribution is to be normal. How many students score 12 and 15? How many students score above 18? Frequency 0 to 0.8, 0.2881. Frequency 0 to 0.4, 0.1554. Frequency 0 to 1.6, 0.4452. X bar equal to 14. Sigma 2.5, n is equal to 1000. Z score we have to find x minus x bar upon sigma, 12 minus 14 upon 2.5 minus 0.8. Z x minus x bar upon sigma, 15 minus 14 upon 2.5 0.4. First Z score is negative. So P score between 12 and 15, A minus 0.8 plus A 0.4. 0.2881 plus 0.1554. 0.4435. Number of student n into P 1000 into 0.4435. 443.5, that is 44,444. Now x minus x bar upon sigma, 18 minus 14 upon 2.5 1.6. P above 18, A greater than 1.6, 0.8, 1.6, 0.5, 0.4452, 0.0548. N into P 1000, 0.0548, 54, that is 55. We have to consult. Same example follow for this example with consult with the weight of 4000 here, 45 and 45 and 60. We solve this way. We have to calculate it in this pattern also. So In this way, we have to discuss the lecture about the normal distribution. Lecture is over.